Welcome to the Introduction to Transaction Processing. My name is Philipp Brune from the Neu-Ulm University of Applied Sciences. When we talk about transaction processing, first we should understand what actually a transaction is. We know that the mainframe is the classical platform for implementing high throughput transaction systems. We discussed this also earlier. Online transaction processing, or OLTP, is therefore a typical strength of the mainframe environment, of the mainframe architecture. We discussed already why this is the case regarding the hardware and I/O system and so on. But first, let's understand what is a transaction. So, in general, a transaction maps a business activity. So a transaction is a business task. If you think of ordering something, booking money, order some good, some product, and so on. These are typical transactions. Customer comes and wants to do some business. And these transactions, or the processing of such transactions, of business transactions, usually involves modifying, accessing data in the systems of a company. And usually it involves the modification of data in different places. So a transaction usually consists of multiple elementary data operations on different data sources, for example. And so transaction processing requires that in a system these data access is synchronized, so we don't get conflicts between concurrent operations, since we must be aware that usually there will be a lot of transactions coming to a system in parallel. In the introduction we heard that, for example, Walmart has 1 billion transactions a day, so there are many transactions that run in parallel in the system and maybe also want to change the same data at the same time, and this has to be synchronized so we don't get mistakes. And that's one of the elementary purposes of transaction processing software. So transaction support, having transaction support is a prerequisite to implement, to write critical business applications. Business applications that really matter, where money is made and where all the assets of a company, for example, are maintained and changed. And this requires to keep the so-called ACID properties. We will just have a look on that briefly. You learned that also in the database part of this lecture. And these ACID properties help to ensure the consistency of the data of an enterprise. So to understand transactions, the most elementary example is always booking money on a bank account. And this is just a brief reminder how this works, or what you have to consider when talking about transactions. So just imagine you have a very simple model of a bank account consisting of a table which has an account number as the key and the balance, the corresponding balance of the corresponding account. Okay? And if you now want to book money from one account to another, which means that you reduce the balance of one account and increase the balance of the other one, if you just think about a standard SQL database, you might know that this would be done using update statements. And if you look at the update statements, you see that for this simple thing, booking the money, you need 2 update statements, one modifying the source and one modifying the target account. And of course, it's obvious that for business reasons, these 2 update statements always need to be executed together. You are not allowed to execute only one, because this would lead to money disappearing or money just appearing out of nothing. This is not okay. So we can say that this is a typical example that these 2 update statements need to be atomic. They need to be executed always both on no one of it. So atomicity is an important property, and this is ensured by transactions. So a transaction in general is a sequence of data operations that starts with the beginning of transactions, then we have the data operations, and then there's an end of transaction, and after the end of transaction, the transaction is either committed, if everything went successfully, or upon failure it is rolled back, so the system is in the state like the transaction never would have been executed. Okay? So this is the basic concept of transactions, and you know that, for example, from database systems. most database systems support such kind of mechanisms on their data that's stored inside that system. So the ACID properties mean a transaction in general needs to be atomic. So this means that it always is executed all or nothing. It needs to preserve consistency of the data. So the data needs to be in order and all the references need to be correct before and after the transaction. Transactions need to be isolated. This means that the system should behave like one transaction was executed independently of the others, and this could also be understood as a serialization, meaning that all transactions should behave like they would have been executed one after another in a strict serial order. And the last one, of course, is durability or durable. The changes made during a transaction after a commit need to be durable, persistent in the system, so they should not be able to disappear or changed without control. So that means that they should remain. Okay? So these are the 4 criteria or properties, ACID properties, that every transaction in a business-critical application needs to fulfill. You learned that already for database systems. If you think of a database management system, typically an SQL or a relational database system, then you have, of course, the support for transactions inside that database system for all the data that is stored in that system. So on the mainframe, this could be, for example, a DB2 instance. However, in a business scenario, typically we have more than one database system or any other data store. We have multiple systems, and we also have different kinds or different types of data stores. Just think of a typical environment, for example, where you maybe have a database where some orders are, and another database that is from the booking system. And if you change, for example, an order, you might also have to change something in the accounting. So you might have 2 database systems, maybe even from different vendors or from different other applications. So in a general modern complex business application, you might have multiple relational or any other database management systems that are involved in a process, in a business process, and therefore also maybe involved in a transaction. And you might have other data sources. On ZOS mainframe systems, for example, we have very frequently the traditional index sequential data sets, which are originating from the VSAM access method. Or we might have messaging. We have MQ message queues, which is also a message queuing system that is available for ZOS for many years. A queue you can imagine as a FIFO, first in, first out. A sender puts in messages in the queue, and a receiver reads out messages from the queue, and the input and output of the messages in the queue is also transactionally secured. So if, for example, the sender commits the message, then the message queuing system needs to ensure that this is also durable and persistently stored in the queue. So these are different types of applications of systems that each for itself behaves transactional. But now we have a transaction which spans multiple of these systems. We call these systems the transactional resources. So we have different systems that by itself are capable of handling transactions inside, and they serve as a transactional resource for some so-called distributed transaction that spans, or the operations of the transaction span multiple or involve multiple of these transactional resources. So the question is now, how can we ensure transactional properties when we combine multiple systems? That each of it has transaction support, but how do we ensure their ACID properties if the operations span multiple of these systems? And that is the purpose of distributed transaction processing, and this is usually implemented using a software component, a so-called middleware, which is called Transaction Processing Monitor, or TPM. Transaction Processing Monitors is a type of middleware, a type of software where different offers, commercial offers are on the market, also open source offers are on the market, of software that is actually there to provide the functionality to handle these distributed transactions. So if you think of the example, a distributed transaction would be a program that modifies different or executes operations on different transactional resources. For example, it reads something from this DBMS, inserts something in the other DBMS, puts a message in the queue, and maybe also reads some vSAM data during executing this transaction. So all these operations need to be part of this atomic operation between the begin of transaction and the end of transaction. And this is now a distributed transaction, since you see that it involves different data sources. And what does it mean? Well, it means that in the beginning, the transaction processing monitor opens up a transaction, this transaction bracket on all the resources. Then there are all the commands executed. And at the end, there's the end of transaction. And now, of course, we have to synchronize the different resources. So what the transaction processing monitor does is actually he sends a so-called prepare for commit operation. At the end of the transaction, he sends a prepare for commit first to all the involved parties. And every involved party needs to check, okay, regarding my internal state, am I able to commit this transaction, or is there some inconsistency, something happened in between that prohibits committing the transaction? And in this case, he sends back a feedback and says, so to the transaction processing monitor, okay, I'm ready to commit. So the transaction processing monitor collects the responses of all involved parties. And if all of parties signal, okay, I'm ready to commit, then the actual final commit is sent simultaneously to all of them. If one of the parties says, no, I'm not able to commit, then a rollback is sent to all of them and the transaction is completely rolled back. So that is the functionality that the transaction processing monitor actually implements to support distributed transaction. And this mechanism is called the two-phase commit protocol. Two-phase commit because we have first the prepare phase and then the actual commit phase. In addition to supporting distributed transaction, typical transaction processing monitors support also front-end logic, so that clients, users are able to start these transactions, and of course they support handling these transaction programs. So this transaction needs to be written in some programming language and needs to be loaded and executed inside this middleware, so the middleware can control what's happening. And of course this requires some infrastructure to start and run these transaction programs. And this is implemented by typical transaction processing monitors. Transaction processing monitors is therefore a category for software that has been around for many years, from the early days of computing, starting on the mainframe. So the first transaction processing monitor emerged from the software called Sabre, the Standard Airline Booking and Reservation System, which was a customer project that was implemented already in the early mainframe days for airline reservation, and later on the core functionality. And in this project, actually the distributed transaction processing was implemented, and then the core functionality was carved out and encapsulated in a separate product over the years. And this evolved to the very famous transaction processing monitor by IBM for the mainframes and other platforms called CICS or KICS, the Customer Information Control System. And this is probably the most well-known classical transaction processing monitor. There are others, not only by the mainframe vendors. For example, in the Fujitsu mainframe world, we have the OpenUTM product, which is also a transaction processing monitor. And IBM also has a second one in the portfolio called the IMSS-TM, so the Information Management System, which is really a database management system, but it offers a transaction processing monitor component that can be also used independently of the actual database. So that is also one transaction processing monitor. And there are, or at least there have been in the past, offers by other companies also for other operating systems like Unix, for example, to achieve this functionality. And transaction processing monitors typically have, as we already heard on the previous slide, different functionalities. So there is always a presentation component that allows the user to interact and start the transactions. In the classical mainframe, this was typically achieved using terminal-based 3270 terminal screens, using, for example, in CICS, the basic mapping support. but today, of course, most transactions are triggered, for example, using a web service from a mobile device or other front-end systems. And then, of course, there's a process control which loads the actual programs, the transaction programs, and executes them under the control of the transaction processing monitor, handling the distributed transaction and two-phase commit mechanism. And then, of course, we need the actual transaction server, which is basically the application program that forms the transaction that is run under the control of the TPM. So using this mechanism, TPMs support distributed transactions, ensure the ACID properties using the two-phase commit protocol. The last type of transaction processing monitor that is sort of a little bit hidden for many people is the Java Enterprise Edition and related frameworks that also have the support for these distributed transactions. So a Java EE, or now since a few weeks it's now called Jakarta EE, and has been handed in the open source to the open source community. So the Java Jakarta EE specification conformal application server is also a transaction processing monitor. So it's very similar to, regarding the concept or the idea, very similar to a classical TPM, just for the Java build. So transaction processing monitors appear in different kinds, and in the following of this chapter of the course, we will have a deeper look on the different types of transaction processing monitor software environments for COBOL, for Java, and so on. Thank you.